What if ancient civilizations, long before electricity, engines, or modern science, mastered technology so advanced we still can't fully replicate them today? From megalithic marvels to rust-proof iron and self-healing concrete, their brilliance defies logic and modern engineering. These aren't myths, they're real enigmas, buried beneath centuries of forgotten knowledge. Join us as we uncover 10 mind-blowing lost technologies that challenge everything we think we know. At number 1, we're setting the seas ablaze with Greek fire, the Byzantine Inferno. Imagine a weapon so terrifying that it changed the fate of empires. Welcome to the mystery of Greek fire, an ancient incendiary substance wielded by the Byzantine Empire with devastating effect. This liquid weapon could ignite on water, cling to enemy ships, and burn with relentless intensity, earning a reputation that chilled adversaries to the bone. Believed to be a combination of pine resin, naphtha, sulfur, quicklime, and pitch, its exact recipe was fiercely guarded and lost with the fall of Constantinople. Despite exhaustive modern experiments and sophisticated chemical analyses, including polymer engineering tests and exothermic reactions, the formula remains beyond our reach. Research at Aristotle University suggests that a mix of pine resin and lime water creates a sticky, burning matrix, yet this fails to fully replicate the seaworthy adhesive effect documented in historical texts. The real enigma lies not just in missing ingredients, but in the ancient process, temperatures, purity, sequence, all possibly passed down orally and lost with time. Scientists armed with modern tools like differential scanning calorimetry and rheometry still struggle to recreate Greek fire's legendary properties. This highlights a powerful truth. Some ancient technologies weren't just formulas, they were refined crafts, combining empirical knowledge, skilled intuition, and material science into a synergistic whole that's virtually impossible to reproduce today. Greek fire remains a burning mystery in the annals of ancient warfare, literally. At number 2, we're drawing swords of legend. Damascus steel, the unbreakable blade. Coming in sharp and mysterious, Damascus steel remains one of history's most fabled lost technologies. These legendary blades were not only stunningly beautiful with their hypnotic wavy patterns, but they were also unmatched in durability, sharpness, and flexibility. Originally crafted using wood steel from ancient India, the metal was renowned for its ability to bend without breaking and slice through almost anything with surgical precision. What made it truly extraordinary was its microstructure. Studies suggest the presence of carbon nanotubes and nanowires, giving it remarkable strength and resilience. Despite centuries of technological evolution, modern metallurgists have failed to replicate its exact properties, often producing pattern-welded blades that mimic the look but not the legendary performance. The secret likely lay in a precise combination of unique ore compositions, trace impurities, and a meticulously controlled forging process. Historical evidence points to specific iron sources in India and Sri Lanka whose unique metallurgical properties played a vital role, resources that may no longer exist. The decline of Damascus steel around 1750 remains unexplained, but is possibly tied to disrupted trade routes, extinction of ore deposits, or the deaths of master blacksmiths who took their secrets to the grave. This lost art reminds us that craft-based technologies, rooted in nuanced practices and oral transmission, are as fragile as they are brilliant. Once broken, incredibly difficult to revive. At number 3, we're tapping into the tremors of time. Zhongheng's seismoscope, the earthquake oracle. Let's shake things up with one of the most astonishing and baffling ancient inventions. Zhongheng's seismoscope, a marvel from 132 AD that could reportedly detect earthquakes hundreds of miles away with pinpoint directional accuracy. This intricate bronze urn, adorned with ornate dragons and toads, is said to have used a sensitive pendulum mechanism to trigger a falling ball from a dragon's mouth into a toad's, indicating not only the occurrence of an earthquake, but the exact direction of its epicenter. Despite the historical record of its eerie accuracy, most famously predicting a quake over 250 miles away before any tremors were felt, no original schematics or detailed internal diagrams have survived. Modern recreations in the 19th and 20th centuries, including a 2005 attempt by the Chinese Academy of Sciences, have yet to fully match the reported capabilities, casting doubt on the exact functioning of the original device. Some historians even question whether the seismoscope truly worked as described, or whether time and legend have exaggerated its prowess. But if it did function as claimed, it would mark a technological leap centuries ahead of its time, involving mechanical engineering principles and vibration sensitivity that still puzzle scientists today. Whether ancient genius or embellished myth, Zhongheng's seismoscope remains one of the most captivating and inaccessible relics of early scientific innovation, a true oracle of the earth that leaves more questions than answers. At number 4, we dive into the depths of ancient genius, the Antikythera Mechanism, Greece's analog computer. computer. From the depths of a shipwreck near the Greek island of Antikythera emerged a rusted lump of bronze that would later rewrite everything we thought we knew about ancient innovation. This object, now known as the Antikythera Mechanism, turned out to be a 2,000-year-old mechanical marvel, a complex analog computer capable of predicting astronomical events, eclipses, and even the dates of the ancient Olympic Games. Consisting of over 30 intricately meshed bronze gears, some with teeth mere millimeters in size, the device showcased a level of mechanical sophistication that wasn't seen again until at least the 14th century. Utilizing epicyclic and differential gearing, the mechanism could model the movements of the sun, moon, and planets with astonishing accuracy. Modern engineers and historians have spent decades analyzing it using X-ray tomography, 3D reconstructions, and digital modeling. Yet replicating its precision and manufacturing method with ancient tools remains a Herculean challenge. The impossibility of reproducing its micro-scale gearwork using Bronze Age equipment suggests that the Greeks had achieved a level of fine tool craftsmanship and astronomical understanding far more advanced than previously acknowledged. Scholars believe the mechanism wasn't a one-off invention, but the result of a now-lost tradition of mechanical engineering, possibly produced in a specialized workshop of elite artisans and astronomers. Its disappearance represents a catastrophic loss of intellectual infrastructure, pushing back the timeline of precision mechanics by over 1,000 years. This device is not just a singular wonder, it's a symbol of technological amnesia, where a civilization's pinnacle achievement vanished into legend, taking with it an entire paradigm of thought and craftsmanship. At number 5, we're tuning into a sonic mystery, Stradivarius violins, the unattainable sound. For over 3 centuries, the violins handcrafted by Antonio Stradivari have stood as the gold standard of musical excellence, praised for producing tones so rich and resonant that they've captivated audiences and baffled scientists alike. Despite countless experiments by modern luthiers and acousticians, no one has been able to fully replicate the Stradivarius sound. Analyses have ranged from the density of the spruce and maple woods, possibly influenced by a 17th century mini ice age, to the chemical treatments used in the wood, such as calcium, aluminum, and even barium sulfate, all detected through microscopic shavings. Other theories revolve around the unique application of protein layers before varnishing, or the finely balanced structure of the instrument's body. However, even with modern acoustics labs and blind listening tests, many fail to detect a consistent difference between Strads and top-tier modern violins, raising a possibility that the Stradivarius effect may be as much psychological and cultural as it is acoustic. Still, these instruments sell for millions, and their mystique remains unshaken. This paradox leads to an intriguing question. Is the technology truly lost, or is it a combination of natural aging, historical reverence, and artisan intuition that simply cannot be engineered on demand? The Stradivarius puzzle likely lies in a multivariable formula: climate, mineral-rich treatments, expert craftsmanship, and centuries of maturation, all converging in an unrepeatable harmony. As such, the legacy of Stradivari may be less about an isolated secret and more about the impossibility of recreating a once-in-history confluence of science, skill, and serendipity. At number 6, we're rocking the foundations of earthquake engineering. Inca seismic-proof masonry, stones that dance with the earth. Perched high in the Peruvian Andes, the remains of Inca cities like Sacsayhuaman and Machu Picchu reveal an astonishing feat of ancient engineering. Stone structures so precisely fitted and resilient that they've withstood centuries of powerful earthquakes. Known as Inca seismic-proof masonry, this construction method involved shaping massive granite and andesite blocks, some weighing over 100 tons, into complex, interlocking forms without the use of mortar. These stones were carved with such precision that not even a razor blade can fit between them, allowing them to pivot and settle during tremors, absorbing seismic energy rather than cracking under pressure. Modern engineering simulations have confirmed that these structures can shift laterally by 2 to 3 millimeters, a design principle still admired today. However, despite high-tech tools like laser scanning and robotic milling, contemporary attempts have failed to reproduce the same structural integrity using only the tools available to the Incas. Some even speculate the existence of a stone softening plant, a legend that hints at possible lost chemical or botanical knowledge capable of reshaping rock, a theory bolstered by studies showing that organic acids can dissolve or etch stone over time. Whether this idea is fact or folklore, the absence of tool marks, the precision of cuts, and the seemingly impossible transport of these boulders over rough terrain continues to puzzle modern archaeologists. Inca masonry wasn't just about building to last, it was about building with nature, harmonizing form and function in a way that modern construction still struggles to achieve. Their methods represent a sophisticated, environmentally attuned architectural philosophy, now lost to time, but etched forever into stone. At number 7, we enter the realm of giants, the Baalbek megaliths, stones that shouldn't move. Towering in the Bekaa Bekaa Valley of Lebanon, the Baalbek megaliths represent one of the most mind-bending architectural enigmas of the ancient world. Beneath the Roman Temple of Jupiter lie colossal foundation blocks, known as the Trilithon, each weighing around 800 tons, and nearby lies the Stone of the Pregnant Woman, a staggering 1,000-ton limestone behemoth still resting in its quarry. These stones were not only quarried but somehow transported over half a mile uphill and positioned with extraordinary precision atop a 20-foot-high platform, feats that defy the capabilities of known Roman technology, which maxed out at lifting around 60 tons. Attempts to recreate similar tasks today, such as the 2014 experiment with a 10-ton replica, have failed miserably. Even with modern knowledge and manpower, the grooves found in the quarry floor suggest levering or rolling systems that have been lost to time, and no known system of cranes or sledges accounts for the manipulation of such vast weight. This has led to a cascade of speculation, from forgotten mechanical systems to fringe ideas involving acoustic levitation or anti-gravity principles. While the latter may stretch scientific plausibility, they reflect a deeper truth. Conventional explanations fall woefully short. These megaliths demand a reevaluation of historical timelines and technological capabilities. The stones themselves aren't just massive, they're silent monuments to a lost engineering paradigm, one that perhaps harnessed principles of balance, leverage, or resource coordination far beyond what we've attributed to any known ancient culture. Until we can move a 1,000-ton stone uphill without breaking a sweat or a crane, Baalbek remains unsolved. At number 8, we ascend history's greatest enigma, the Great Pyramid of Giza, Pharaoh's perfect puzzle. Rising from the desert sands like an eternal riddle, the Great Pyramid of Giza is more than just an ancient tomb. It's a towering conundrum of unmatched precision and scale. Built over 4,500 years ago with an estimated 2.3 million limestone blocks, each averaging 2.5 tons. This massive structure aligns to true north with an error of only 0.05 degrees, a level of precision even modern surveyors admire. The pyramid stone blocks were transported across miles from quarries and placed with such tight tolerances that not even a credit card can slide between them. Mainstream theories suggest ramps and sledges powered by manpower and copper tools, but the math doesn't add up. To complete the pyramid in 20 years would require placing one block every 2 minutes, non-stop. Experimental reconstructions have consistently failed to replicate this efficiency or precision. Some scholars propose spiral ramps inside the pyramid, while others speculate about lost techniques involving water flotation, specialized abrasives, or completely unknown methods. One particularly confounding clue lies in the granite sarcophagus found in the king's chamber. It's too large to fit through the internal corridors, implying it was installed during construction, revealing a complex awareness of sequencing and logistical foresight. The Great Pyramid's construction speaks not only to raw manpower but also to a sophisticated mastery of planning, coordination, and material science, a lost system of knowledge that defies simplistic explanations. It raises a profound question. Did ancient Egyptians possess a technological methodology we have yet to understand? Or has a chapter of advanced ancient engineering been completely erased from history? Number 9. The Iron Pillar of Delhi, the rust-proof enigma. In the heart of Delhi stands a pillar that has defied both time and nature, a 23-foot, 13,000-pound iron monolith that has stood outdoors for over 1,600 years without rusting. Erected around 400 AD, the Iron Pillar of Delhi resists corrosion in a way that modern steel struggles to match. At a time when untreated iron structures corrode within decades, this ancient marvel has endured uncoated and exposed, leaving metallurgists puzzled for over a century. Modern analysis reveals a unique metallurgical composition, unusually high levels of phosphorus and an absence of sulfur and manganese. This composition enables the formation of a thin, protective passive layer of misowite, delta FeOOH, that prevents further rust from penetrating the iron, essentially creating a naturally self-sealing barrier. But understanding the chemical properties is one thing. Replicating the original process using ancient techniques is quite another. The iron pillar wasn't cast in a mold or forged from modern alloys. Whether formed by forge welding layers or forged as a single shaft without visible seams, the process remains mysterious. No welding tools from that era capable of such work have been found, and the precision of the final product is striking. The creators, without any concept of rust resistance, seem to have empirically achieved one of the greatest feats in metallurgical history. This raises compelling questions. Was it the product of a lost tradition of empirical trial and error spanning generations? Did ancient Indian blacksmiths develop a technique so advanced that it rivaled 20th century metallurgy? Though we understand the chemistry today, the true lost technology lies in how such knowledge was discovered and practically applied centuries before modern science caught up. The Iron Pillar doesn't just resist time, it mocks our assumptions about the pace and progression progression of technological evolution. Number 10. Roman self-healing concrete. The ruins of Rome still stand, not as mere remnants, but as living monuments to a forgotten genius, one embedded in the very material that holds them together. Roman concrete has lasted over 2,000 years, while modern concrete often crumbles within decades. For centuries, historians believed its strength came simply from volcanic ash, but recent discoveries reveal something far more advanced. Roman concrete heals itself. At the core of this ancient innovation lie tiny white fragments called lime clasts, long thought to be signs of poor mixing. In truth, these clasts are reactive pockets of quicklime created through a hot mixing process. When cracks form and water enters, these clasts react, producing calcium carbonate that seals the cracks. This means Roman concrete doesn't just resist damage, it actively repairs itself, gaining strength over time. Even more astounding is its marine resilience. Structures like harbors constantly battered by seawater have not only survived, but hardened over centuries. When exposed to seawater, the Roman mix forms rare minerals like aluminous tobermarite and philipsite, which reinforce the structure from within. In contrast, modern concrete designed to be inert degrades in similar environments, highlighting a fundamental philosophical difference. Roman engineers embraced materials that evolve with their environment. This is more than a lost recipe, it's a lost mindset. Modern engineering aims for stability. Roman engineering anticipated adaptation. The Romans likely refined their formula over centuries of observation, trial, and iteration, something modern construction rarely permits. Their secret wasn't just what they mixed, but how they thought. Today, researchers race to create self-healing concrete using bacteria or capsules. Yet even with cutting-edge tools, the Roman formula remains unmatched in its simplicity, durability, and ecological harmony. The true mystery isn't merely chemical, it's historical. How did ancient engineers intuit processes modern science is only beginning to rediscover? From rust-proof iron and self-healing concrete to ancient computers and unbreakable blades, these lost technologies remind us that our ancestors were far more advanced than we often imagine. They challenge the idea that history moves in a straight line and reveal just how much genius may have been buried by time. As we continue to uncover these ancient marvels, one thing is clear: the past still has secrets that could shape our future. Don't forget to like, comment, and subscribe for more mind-blowing journeys into the mysteries of history. Thanks for watching.